All right, welcome to the first lecture of Introduction to Logic. This is Philosophy 60. I'm Randy Mays, and we're going to be covering chapters 1 and 2, Argument Structure and Evaluation today, from this book right here. This is the required text for the course, and it's also might look like this. Either one is fine. They both cover the same material. The recommended text is this larger one. All three of them are part of the Shalm series, Shalm outline of this and that. They're really good books. They're very inexpensive, and they cover their subject matter extremely well. So if there's any other subjects you're interested in studying, I'd recommend checking the other books out in this series. Now, one downside of these is that they're not available in a Kindle version, an e-text version, which I don't like. I would really like to be able to make this kind of stuff available to you in an e-text, and usually I try to do that. But these are so inexpensive, and sometimes it's just it's easier to do logic on paper. Okay, let's get started. Let's define logic first of all. Logic is easily defined as the study of correct reasoning. Now, this word correct you might think is kind of loaded. I don't know, you might be the sort of person who has a sort of an instinctive negative reaction to something like that and wants to say who's to say what's correct reasoning and what's not. But don't worry too much about that. We define this notion of correctness technically, and it's not a definition you have to accept in real life, but it's one that's turns out to be very productive for this subject. Okay, so we don't do informal logic, we're doing formal logic, but it's good to know the difference. So if you took a critical thinking class before, you were doing what we essentially call informal logic, at least sometimes, and that's the study of correct reasoning using natural language. That's the language you speak, like English, Spanish, or Chinese. Using that language to study the reasoning that occurs in it. Now we're going to be studying formal logic, and formal logic is the study of correct reasoning in a symbolic language that's created, that's been invented for the specific purpose of representing logical relationships. Well, it's a little abstract, but an analogy with math can help here. You know, if I asked you, hey, write down 3 times 7 equals 21, it's really unlikely that you would write this out in English, right? That would be a very odd thing to do. Even if you're not a big math person, you'd almost certainly write it like this. And you'll notice that's a really different way of writing that. This is actually written in a different language. This is the language of mathematics. And they both mean the same thing, of course, but the first sentence is written in English and the second it's written in mathematics. And obviously the reason you'll usually prefer to write the expression in the second way is that it represents mathematical relationships more precisely. Makes it easier to think about them, and it makes the calculations a lot easier to do. That's something you know already. So that's actually what's going on in logic as well. So in logic, we represent reasoning with structures called arguments. So math uses equations, logic uses arguments. Now, an argument can be defined like this. An argument is a series of statements called premises that are meant to support another statement called the conclusion. So premises usually followed by a conclusion, premises supporting the conclusion. Now, it's important to understand that in logic, the term argument it's defined technically. It doesn't have anything to do with the ordinary meaning of an argument as, say, a heated verbal exchange or fight. It's true that people may engage in ordinary arguments by making these technical arguments, premises followed by conclusion. But people who just shout their opinions at each other, they're not giving any rational basis for them, or fighting. They're not giving arguments, even though we would ordinarily say that they're arguing. It's just two different senses of the term. So that sort of fighting notion of arguing is not what we're interested in this class. Okay, well, let's look at an example of say a moderately complicated argument in English that you'll probably still actually find pretty easy to follow. So a student says, my assignment would be better if I took one extra day to complete it. But if I took one extra day to complete it, the assignment would be downgraded by 20%. I don't think I can make it more than 10% better in one day, so I might as well just turn it in now. Pretty easy to understand, right? Well, we can take this argument and put it into what logicians call a standard form by writing them as a series of premises followed by a conclusion, right? So sentences 1, 2, and 3 are the premises. You'll recognize them. And sentence 4 is the conclusion. That's the statement that the other sentences, the premises, are trying to support. We draw the conclusion from the premises or on the basis of the premises. That's actually very typical to say words like so, or therefore, thus, hence, all of those to signal to the other people we're talking to that we're drawing a conclusion, and we mean for them to draw it too. This is stuff you know already, of course, so maybe that's a little comforting at this point. Well, we can also go one step further, and this is what we're going to be doing in this course. We can take the argument and we can formalize it. So if we were to use propositional logic, which is what we're going to be studying very soon, to represent this argument, it would end up looking something like this. So again, 3 sentences followed by a conclusion. And each of these is the formal interpretation of the sentence it represents. So each of these capital letters represents an entire proposition or statement. So for example, P here represents the proposition, I take one extra day to complete my assignment. And that's something that occurs twice in the first 2 premises, right? If you go back, I take one extra day to complete my assignment. If I take one day to complete my assignment, it will be better. This proposition, I take one extra day to complete my assignment, occurs in premises 1 and 2, and so that's why P occurs twice. This says if P then Q, this arrow, which we'll learn later, represents something we call a conditional. If P then Q, if P then R, S, therefore T. So each of these capital letters represents an entire proposition or statement. P represents the proposition, I take one extra day to complete my assignment, and so forth. The arrow is the formal way of representing a compound sentence of the form if then. which we call a conditional statement. These are all things we'll be learning later. Now, we said that logic is the study of correct reasoning. In logic, correct reasoning is reasoning that preserves the truth, preserves it. Now, preserves means if it's there already, it'll stay there, right? It doesn't create truth, it preserves truth. So put differently, correct reasoning is reasoning in which the premises, if true, would necessarily lead to true conclusions. Put truth in, you automatically, necessarily get truth out. So when we put this technically, we use another technical term, validity or valid, or more precisely still, deductive validity or deductively valid. All right, so one precise definition of deductive validity is this. An argument is deductively valid if and only if its conclusion is true whenever its premises are all true. You might as well know right now that this phrase, if and only if, is a very common one in logic, and we typically abbreviate it as IFF. So I'll often write it like that. Okay, an argument is deductively valid if and only if its conclusion is true whenever its premises are all true. Now again, the term valid is a technical term for us. In English, we use the term to mean a lot of different things, but in logic, it means just what we said and nothing else. However, there are many ways of expressing logical validity that mean the same thing, that are what we would say are logically equivalent. So here's some other common ways of defining logical deductive validity. So an argument is deductively valid if and only if it is impossible for the premises to be true and for the conclusion to be false. Okay, so if you think about that, it is impossible for the premises to be true and at the same time the conclusion to be false. In other words, if the premises are true, the conclusion must be true. Or alternatively, an argument is deductively valid if and only if, given the truth of the premises, the conclusion must also be true. Okay, so again, it would be impossible for the premises to be true and the conclusion false. Now, it's very common for people to think they understand the concept of validity when they're actually confusing it with the concept of truth. So valid is a kind of goodness, right? It's a good thing. It's a form of correctness. And truth is certainly a good thing. We have sort of pleasant, positive, good feelings about validity and truth. And because of that, we often tend to confuse them a little bit. So here's an argument. Again, 3 premises and a conclusion. Think about it for a second. All dogs can whistle. All cats can yodel. Every single animal is either a cat or a dog. Therefore, every animal can either whistle or yodel. Now, what do you think about that? Do you think it's valid? Well, it is valid, as a matter of fact. All dogs can whistle is not true. All cats can yodel is not true. Every animal is either a cat or a dog is certainly not true. But if these are all true, then this has to be true. Okay? If all dogs can whistle and all cats can yodel, and every animal is either a cat or a dog, then every animal will either be able to whistle or yodel. This will follow necessarily from these premises. So there is nothing here that's true, not remotely true, but this is a completely valid argument. Okay, so people who say the argument is not valid are usually just temporarily forgetting what validity means. It's pretty obvious that whenever the first three statements are true, the conclusion is true. Problem is that the first three statements are so clearly false that we find ourselves wanting to call it invalid for that reason. So the important point to remember is that validity has nothing at all to do with the actual truth of the premises. It only has to do with what happens to the truth of the conclusion if we make the assumption that the premises are true. Well, just like doing complicated math problems in English, determining whether an argument made in English is deductively valid can be extremely difficult. For example, is this argument valid? Bob loves only people who don't love him. So if Bob loves himself, then Bob is a vampire. Well, that's ridiculous, right? It's certainly bizarre. But the words bizarre, ridiculous, and invalid, they're not the same. They are not synonyms. It actually turns out that this argument is deductively valid, but we're going to need a lot of formal logic to demonstrate this. All right, the last thing we want to talk about is the difference between deduction and induction. So we'll be studying almost exclusively deduction in this class, but there's a whole other field of inquiry of logic called inductive logic. So in inductive logic, you study inductive arguments. And so let's see if we can understand the difference between the two. A deductive argument is one in which the premises are intended to deductively imply the conclusion, which actually means that the argument is deductively valid. It's another way of saying that. An inductive argument is one in which the premises are intended to confer a high degree of probability on the conclusion, to make the conclusion very likely. So we often characterize arguments that succeed in this way, that in fact do succeed in making the conclusion not just seem likely, but be actually likely on the basis of the premises, on the basis of the truth of the premises. We often call these inductively strong arguments. So here's a simple deductive argument. Sam is a gardener. All gardeners are lovers of nature. So, therefore, hence, Sam is a lover of nature. Now you can probably see pretty easily that this is a valid, right? This is a deductively valid argument. Premises 1 and 2 definitely together imply the conclusion. Well, here's an inductive argument. Same subject matter. Sam is a gardener. Not all, but most gardeners are lovers of nature. Therefore, Sam is a lover of nature. Now, it's easy to see that in this argument, it seems very likely that Sam is a lover of nature, but you can also see that it's possible that he's not, since it only says that most gardeners are lovers of nature, not that all of them are. So Sam might be one of those few gardeners who is not a lover of nature. One of the interesting differences between deduction and induction, between deductive and inductive arguments, is this. A deductively valid argument remains deductively valid no matter what premise you add to the argument. So let's add a premise. Sam is a gardener. All gardeners are lovers of nature. But let's add another premise, premise 3. Oh, by the way, Sam hates camping. Now, if I just told you Sam hates camping, it would be very odd for you to conclude that Sam is a lover of nature. Not liking camping doesn't seem to go with being a nature lover. So that seems to be information that would tend to undermine the conclusion. But it doesn't actually in a deductive argument, because these are still both part of the argument, right? So from Sam is a gardener and all gardeners are lovers of nature, it follows deductively that Sam is a lover of nature. And if and as long as those two premises are there, then we still have a deductively valid argument. So because this conclusion follows from premises 1 and 2, it also follows from premises 1, 2, and 3. Now, that's the difference, the main difference between a deductively valid argument and an inductively strong argument. Because once you add this third premise to the inductive form of this argument, so Sam is a gardener, most gardeners are lovers of nature, Sam hates camping, therefore Sam is a lover of nature, what you've actually done is made this an inductively much weaker argument. And why is this? Well, because from these two premises, it does not necessarily follow that 4 anymore. So this 3 now counts as more information about Sam that would tend to undermine this conclusion and weaken the argument generally. So you can't weaken a deductively valid argument by adding new information, but you can weaken an inductively valid argument by adding new information. Okay, so in other words, the fact that Sam hates camping gives us a reason in this inductive context to suspect that he's one of those gardeners who doesn't especially enjoy nature. Now, you might wonder, why did we talk about inductive logic, inductive arguments, since that's not what we're studying in this class? Well, partly it's because it's in the book, but also partly because we do teach inductive logic. The course is called Philosophy, not surprisingly, 61. I teach that course too, and it's taught by some other people as well. And if you end up liking Philosophy 60, you might end up liking Philosophy 61 as well. It's actually a very mathematical course. Not mathematical in the sense of difficult mathematics, but it does treat probability in mathematical terms. Okay, that's it.